time now for a couple of very short slides that when we were building out our task entity, I introduced one or two new things to you. The first of which was that when you're building out a class with properties or a function with parameters, well, we specify the name of the property or the parameter and then the type. When we say val description of type nullable string equals null, what we've done there is put in a default argument. This allows the user to create a new task object and not actually have to specify the description or is starred, or even our task ID, which has a default argument of 0. We were able to do something like this. If I do a quick test function here, we can do values or properties. Well, this is valid code as the task class has those default arguments. So I'm in a brand new Kotlin Foundations Scratch file called default arguments. If you can go ahead and make the same, and I'll close the project pane for now. I'm starting with a heading that says, however, so say we have a on individual, I have a default here. You might be delivered, and then just one we could say the quantity, and then put that there, and we could give all three arguments. And then if I just drag the preview pane over a little bit, ordering product 512, quantity 3, delivery type next day. This behavior, you want to order one item be used. That's the example. And do note that it is allowed to have a function where every parameter has a default value. Say, for example, we have a function called make coffee. I'll just quickly put in the curly brackets and the normal brackets. So cappuccino, there could be a number of regular. Then order details. Okay. I scroll down and expand this. Okay, one cappuccino coming right up. Order details, no sugar, 2 shots, regular. But of course, scrolling down, okay, one flat white. But for the rest of the arguments, it's parameters. And then scrolling down, this allows calling the function without any arguments, and all the defaults will be used. We'll fall back to definite bonus of the Kotlin language. However, you may have a question with this. Well, in my example with make coffee, if I'm happy to provide the first argument, the coffee type, you can see the little grey prompt we have there, then that's fine, and the rest can be the default. But what happens if I want to only provide the sugar amount, or just the size? And so, another new concept that you may have noted, the descript task, my description, or however, if you look at the code elsewhere, for example, how it's saved, it might not be immediately clear what true refers to. How would we do that? This is a problem because the first parameter is an int, and so this new object is expecting an int. And so I very briefly showed you the idea of named arguments, which is the solution. So there's a function to create not give a default value, social, and by default function to show once I fill all this out. Okay, so just simply printing all those values there so we know it's working. So I can go ahead and create a user and just give it 2 arguments for the 2 parameters that don't have a default value. That is, and when I click and have a look, we have vim. You can put it inside Android Studio. Okay, so just let strings fin again, and welcome email can equal. When using functions with lots and lots of notes straight away, arguments, and an example where you can't do that, the default, the function, okay, so this, with lots of, to pick out one, but maybe it's fine. We have manually called the optional argument or email, don't name any, so we'll put it as a default value. Then on a new line, we'll say, you can specify any parameter orders. You can do is admin equals true, like that. So a quick note to say, named arguments allow us to set the values in any need to use named arguments for that, but that's going to be absolutely fine. So we'll accept the arguments. When you call the functions, you can name them. That's not the case, so you can't see exactly which parameter corresponds, okay? But let's, and also, you can then set them in any order, okay? Referring back to task, this now makes sense. Title was our only non-optional parameter, so by doing title equals the title, we're using named arguments to pick out the one and only one non-optional parameter. And again, just like default arguments, named arguments simply do not exist in Java, and they're just a fantastic benefit of the Kotlin language. Okay, I'm back now in our SQLite playground, that is db-fiddle.com, having changed the database to SQLite, the latest version 3.39, and having learned now about the schema, creating tables, our database's structure, and how that relates to the Android Room entity annotation, we can now dive in and get going with CRUD, creating, reading, updating, and deleting. And so we'll start with the first of those 4 operations, creating data in our database. We will first of all need a table in our database to put data into, so I'll quickly create a table called artist, for a record artist, for a musician. We'll do some brackets and a semicolon that you do need, and we'll have an artist ID, that can be an integer, and then primary key, but then we'll have the artist name, and that can be text. And we'll go ahead and say, not null. And we'll also add their age. I know that's a silly one to have because their age can change each year, should be date of birth really, but just to show some different data types. And we'll say that could be null, there's the option to not set that. So we have our create table artist, and just to the right in the query SQL, we will do select star from artist. And all that will do is it'll select every single row, and the star means every single column from the artist table. So that's what we'll use to show the data that we're putting in. But we'll actually create the data for our database in the schema SQL side. Okay. Now we are focusing in this first tutorial of CRUD on the create command. However, for actually putting data in the database, it's not the word create. It is the word create for making tables, for creating our schema, but actually the keyword for putting things in the database is insert. So putting data in always starts with the same 2 words, insert into, and the next thing we need is the name of our table. So that will be artist. And then there's 2 sections to this. One is which columns do we want to put data in, and then the second part of it is what are the corresponding values. So for example, immediately after the table, you might have column 1, column 2, column 3, and the next section will be values, and then more brackets, value 1, value 2, value 3, and then a semicolon. Should probably put those inside speech marks to be clear, because they would be strings, or text rather. So this is the format. Insert into your table name, then the first of the brackets defining which columns in which order you want to put the data in. Very, very important, because then you say values, and then more brackets, and the order of the values must match the order of your columns. Page. And then we'll do something simple like 1 for the ID. For records, one approach could be to copy this line over and over and over again, making sure the primary key is always unique. I wonder if I should keep it all roughly in the 50s. Let's do Elvis. Long these people left more like the 60s, but oh well. So we could do this, run this, and then we've got 4 records in our database. Of course, the artist ID is an integer primary key, and by default in this version of SQLite, that will auto-increment automatically. So we can remove the artist ID. And of course, we have the option to have different insert statements. We can provide more or less different insert commands, but the format is the same. Insert into the table name, the columns you want to insert, then the keyword values. And notice how I'm putting all of the keywords in SQL in uppercase. You don't have to do that, but that's another very useful SQL convention that many people follow. To put the SQL might be a good idea if you're working with raw SQL. So insert into table name, the name of our columns, then the keyword values, and then more brackets with the actual values. There's not much more to show you on creating data than that, and you're going to see in just a moment with the Android Room library, it's even easier than this. We don't even really need to provide the insert command at all. You're going to see it's probably one of the easiest operations we can do in Room, creating or inserting into our database. There's just one thing I'll show you, and that is rather than having a separate insert into for actually into artist and then the age, and then it's on your line, you can just have multiple pairs of brackets as long as the brackets themselves are separated by commas. So I need to make sure they all have names and ages. So I'll put the stage back in, and I'll do the classic line one, being sure to do the ID, and remember the brackets, and click all of this. So a similar thing, I'll put some tabs in there, but this time we're doing insert into the table name, we're choosing our columns, and it does. Okay, so creating data in SQL is relatively straightforward. The SQL itself isn't too much to understand. Let's fire through the remaining data operations, read, update, and delete, with the next one being read, or selecting data from our database. Moving on now to the read operation in SQL. Note that I'm still in TPFL.com, create my schema. I'm inserting this tutorial. Well, it's similar. So this time, these automatically generated, and then all the first okay, select. I'm going to manually list all the columns, separate by just the columns from the table name, query, some sort of labels, and then so let's now do web department. Next up we have updating data. We have a table for product, quantity, and that price and quantity here. The next column name is 15, up from 10. However, if I just semicolon now and don't provide any further information, try to run this, and I'll just go ahead and underneath it do another select star from product just to make sure you can see the result. But if I go ahead and run this now, providing nothing further this update operation, I just do laptop quantity at to update, we then need where to 15 when the update values, most often a where keyword with a condition. The final of our code operations is delete. And for our select star from, and we'll learn that to delete command here, table name, we'll actually delete it in the table. So let's go ahead and so there's no result to delete, we delete all the data. And just like with the read command and also the update command, we can provide a where command or the where clause to filter the data to find the records that we want to delete. So if we go ahead and do delete from orders where the order ID equals 1, and then on this, query 2, which is our select star from orders, I can see we have order ID 2 to 7, all the for me, Charlie, which is cancelled. We can do and do multiple conditions. Or we'll have Bob because the status is preparing. So we've got the customer equals Bob, we also have the status as delivered. If I can change Bob's record to be delivered like this, well then that does go. So we learned about the and operation when we were selecting data that you can do multiple criteria to find a record. But a new thing I thought I'd show you here is the or command. So we'll go back to the start of the command. So we'll probably want to delete all of the records where the status is preparing and one cancelled. But we cancelled, well that's going to be next. So the keyword we need is the word or, and that is a recognised word in or cancelled, and it's a criteria. We can say with order ID equals 3, semicolon, and when we run that, it will just remove one record. That's quite a common thing to do when we're deleting, to have a specific ID to one of our rows or one of our records, and just delete that one item. You can do a command where you delete multiple things, for example, delete all of the delivered orders, so its status is delivered, and that will delete multiple records. And whenever okay, we're back now in Android Studio, having learned all about CRUD using SQL. I'm in
the task entity, and I'm just going to go ahead and delete that test function. We don't need this anymore. So just this simple task data class, which is an entity, which is a term in Room. We also have our database class here, the getItDone database, and final file for Android Room, and that is going to be the data access object. As we're now going to have 3 separate files all relating to our data and our database, now will be a really good time to reorganize our files into their own package. So on my main package, com.vinnorman.getItDone, I'll right click and make a new package, and I'm going to simply call all of these files data. This is going to be the source of the data for our task app. You can call yours what you want, but data is a pretty good name to gather up all of the files for our database. And I'm going to drag the task class into this data folder and click refactor. I'll drag the getItDone database into this folder and click refactor. I'll just open up the data folder so you can see those 2 files now and there. And I'm going to right click on the data class and create a new Kotlin class or file. And we want this now to be an interface. It could be an abstract class like our getItDone database or an interface, but typically most people use the interface for this. You'll see why in just a moment. So click interface, and this is now our task, and then capital D, DAO. And that stands for data access object, task DAO. So task DAO of type interface, and then enter. And now we're ready to get started. If you remember when I first introduced the idea of a database, I had that funny slide of the butler, this guy that you can see there. And the idea there was that the butler represents SQL. Those SQL commands are the interface. They are the way that we communicate to the database. We give relatively simple instructions in human language, delete from the table where the ID is 4, things like that. And then that butler takes the instruction, goes into the kitchen, tells the database, and the database takes care of the rest. We don't care about the inner workings of the database. But as you maybe saw from the previous 4 tutorials, even using SQL can be quite a bit of work. There's a lot of very different commands to remember. Reading data is select, creating data is insert. There's the where commands, there's selecting the columns. Well, in the Android Room library, the DAO, the data access object, is like an even simpler version of our butler. And to show you what I mean, let's go ahead right now using this task DAO interface and very quickly do our create, read, update, and delete operation for our task, just to see how easy it is. The first thing we need to do for any data access object in Room is annotate the interface, or the abstract class. You're allowed to do both, but we'll go with interface. You need to annotate it with DAO. So at DAO, capital D, and that's going to tell the compiler, the KSP thing, that the code in here is a data access object, and Room knows how to handle that. And then inside the curly braces for the interface, we're going to create 4 simple functions. Remember, for interfaces and for abstract classes with abstract functions, we don't need to provide any code, just the function name and parameters. And our first function will be the create function. So we'll do fun for function, and we'll simply call it create task. We'll give the normal brackets, and then a simple parameter of a task object, the task class. And that's it. We're not going to provide any code. We don't need to. In a moment, we're going to add an annotation to this,
and then that's all that Room is going to need. That's why the task.dao only needs to be an interface or an abstract class, because we're not going to be typing any actual code in our functions. So function create task, and there is a very simple annotation we do, and that annotation is @insert. And that's all we need to type. No SQL commands for this one. In a moment, when we build the app, I'll show you the auto-generated code from this, but this is the point of the DAO, of the data access object in Room. In Kotlin, we're used to interacting with functions, calling a function name, passing in a function parameter. So later on in our app, we're just going to be able to call simply task.dao.createTask. Very, very easy. And under the hood, when this compiles, there's going to be a whole heap of auto-generated code. All the SQL that you saw in the previous 4 tutorials, that's going to be taken care of for us. And how good is that? Let's quickly rattle off the other 3 operations. The annotation for a select command or a read operation in Room is query. I'll just quickly type out the function underneath. So this can be function get all tasks. No parameters, but we're going to return now a list of tasks. And you can see we have an error for the query annotation. So for this one, you do need to provide a little bit of SQL. It needs to know exactly what tasks we want. Do we really want all of them? Do we want a task where the status is completed or where it is starred? So you do need a bit of SQL for reading, for selecting. So we'll do some brackets, and this is expecting a string, which is the query. So speech marks, and I'll follow the convention of putting the keywords in uppercase. So select, and you can see that turns orange. So in Android, the Room library colors the key SQL words in orange, which is helpful. So we're going to choose every column because we want to fully rebuild the complete task class. So we'll do select star from, and then our task table, which we recently renamed to be lowercase t task. So select star from task, and that's it. Easy, right? And we're not providing any sort of where clause, no condition. So that's going to get every single task. So the function is get all tasks. And under the hood, the Room library is going to take care of doing that query, getting the results, and converting that into a list of task objects, which is fantastic. For the update, we will just do @update, nice and easy. And we can make a new function. We can call the function whatever we want. Update task seems appropriate. And for this one, we just pass in another task object, another task argument. And we don't need to provide any SQL for this one, because Room is going to look for the primary key in the task object that we've passed in. Remember, we have a primary key there. So what it will do is, it will search the database for a task with the same primary key, and it will override any of the values in this task object. We'll be seeing this later on when we get our app task saving working, completing tasks, starring tasks, things like that. Okay? So we have create, read, update, and finally we have delete, and again, helpfully, the annotation is the word delete. No need to provide any SQL, and we'll simply call this delete task, and it works very similarly to the update task function we have above. We just pass in a task argument. It will look for the primary key. Doesn't matter what the values of the rest of the fields are. If it finds a task with that ID, it will delete the task. And that's it. Create, read, update, delete. Insert, query, update, delete. Those are our 4 CRUD operations. And how simple is that? Just to round off this tutorial, to see the link between this DAO file that we have here and the underlying code, the SQL that we learned in the previous 4 tutorials, let's include this in our database, build our project, and head once more into the auto-generated code and try and find some of the key SQL syntax that we saw in the previous 4 tutorials. To get this to build in our database, we need to head into our getItDoneDatabase file, and within this abstract class, the getItDoneDatabase, within the curly brackets, we need to provide a function to access this task.dao. So we'll do fun, can call it what we want, we'll say get task.dao, something like that, no parameters, and that can return an instance of our task.dao interface. We don't need to provide any code, but we're getting an error that says function get task.dao without a body must be abstract. We don't need to provide any code for this, just like with our task.dao. So if we put the word abstract at the front, the error goes away. And because we have @database, and we have this get task.dao function within the class curly braces, again, KSP and the Room compiler is going to convert this into all the code that we need, which is fantastic. If I go ahead now and run this to build this code, and hopefully one thing that you've noticed is that the get task.dao function is no longer unused, so there is some auto-generated code that has been made that uses this. And again, the task.dao interface is not unused. Some code has been generated that uses this. So we'll head into our build folder in the app module, we'll go to generated, KSP, Java, and now we have 2 classes that have been created, getItDoneDatabase implementation and task.dao implementation. Okay, so if I click now into the task.dao implementation, and we have 171 lines of auto-generated code, all from this. You see now how useful the Room library is. Now there's quite a lot in this file, but let's try and find some key things. So scrolling up, I can see there's a function here called getAllTasks, and I can see our select star from task query that we wrote. But then there's a whole lot of junk, this Room SQLite query, cursor, getColumnIndex, with all of our task columns. And then scrolling down, I can see we have a while loop that goes round and round for every single item that it finds. It creates a new task object for us from those values, from the strings and integers, okay? And then it returns this list of tasks. So it's doing a lot of heavy lifting for us, and we don't need to understand every single line of this code. We just need to know that the task DAO will do the query that we gave to it, and will take care of converting the results to the object that we need, which in our case is a list of tasks. Okay? Scrolling up a bit further, we have some strange adapters and other bits of code that the Room library creates. But we can see here we have an insertion adapter, and under the hood for this we have insert or abort. We didn't cover that, but don't worry too much about that. Insert into task, and then we have the 4 columns, task ID, title, description, isStarred, and then values, and then some weird things with question marks. And SQLite and Android has a way of using question marks as wildcards and inserting the values into those question marks. We don't need to care at all about that, but the syntax is very similar. Insert into task, these columns, and then these values. A bit further down we have the deletion adapter. Delete from task, where the task ID equals question mark. This should seem very familiar from the previous tutorial on deleting. Delete from table, where, and then some condition. And again for update. Update, or abort. But then we have update task, and then set all of the 4 columns, where the task ID equals question mark. Okay? So that is the point of the DAO, or the data access object in Room. Something as simple as this is all that we need to write to create, read, update, and delete tasks. And Room then generates all of that complexity for us. So when we make our app, we only need to interact with this. Simple functions with simple parameters or simple return types. Things that we're very, very used to in Java and Kotlin. And this concept of the data access object, this leads very nicely into a major programming concept for this section, and that is on the object relational mapper. How we can go from all of this raw data, these raw SQL commands and results, into things that we know, which are task objects, or list of tasks. So let's cover the concept of ORM, object relational mappers, next. Time now to understand the concept of the object relational mapper, commonly referred to as ORM. First of all, some quick recap. Java and Kotlin utilize object-oriented code. We already know this. We make classes, blueprints, and then from that class we can create objects, instances of that class. And in our code we are very, very used to handling the creation of objects, updating objects, passing them around. We often use it for passing around data in the form of a data class in Kotlin. This is a simple class with various properties. And for example, in our getItDone project, we have the task class. And from this we can make various task objects. So Java and Kotlin use object-oriented code. SQL databases are relational. We don't have the concept of classes and objects in SQL or in relational databases. We have tables, columns, rows, and then we may have data in one table that relates to another table, and this is what makes it relational. A complicated schema for a relational database could look something like this. Numerous tables, the table names there in orange, with all of the columns, all of the structure for that data type, and then the orange lines representing the relationships between those tables. So, an object relational mapper maps the relational data to objects in our code. Simple as that. The clue is in the name, object relational mapper. So we may have in our database tables, columns, rows, and this then maps to classes and objects. For example, our data class. And object relational mappers aren't just exclusive to Android, they exist everywhere in many programming languages, in many different software products. To understand their value, let's first consider without an ORM. This is the code that we would need to type in Android to convert the database results into a list of our task objects. Now take a moment to digest this. We have some function called getAllTasks with an SQLite database object, and we would need to do a raw query on this database, select star from task, do a quick check to make sure that it's not null, that query doesn't fail and not find the table or something like that. And that returns a thing called a cursor in the version of SQLite that runs inside of Android. And then we need to loop around that cursor with cursor.moveToNext. And this cursor is a collection of rows, with each row having a column and then some data in that column. So to get the 4 values for one record, a task ID, title, description, and isStarred, we need to call cursor dot, and then getInt or getString, and then we need to pass in the index of the column given. Cursor.getColumnIndex, task ID, title. You don't need to memorize this or learn this syntax. This is the old way of doing it before Android Room. Very, very cumbersome. And as we loop round and round with this while loop, we get those values in that very cumbersome way, and then we build out a new task object, as you can see there, manually from those values. and then we add it to our list one by one, and then we keep looping round and round and round, manually building out those objects from the data, the raw data in the database. So here we are mapping the database values to our recreated objects ourselves, and it is a lot of work and very, very susceptible to mistake or human error. Well, Room is an ORM. That's essentially its entire purpose. To take away all the pain and complexity of working with databases manually, working with the raw SQL, and then rebuilding the objects, Room's job is to do all of that for us. So, with an ORM, in our example Room, we get code that looks like this. A simple function with a query, select star from task, and that will automatically return us a list of tasks. ORMs are very common in object-oriented programming languages, not just Java and Kotlin. And now that we've gone through our SQL tutorials and learned the basics of create, read, update, and delete, and then we've seen how that relates to Room and how the data access object automatically creates that code for us, hopefully now you understand how valuable and fantastic ORMs can be. Just to put this into a wider context, here are some other famous popular ORMs that you might have heard of in other programming languages. There's Hibernate, Django for Python apps, the Entity Framework for the Microsoft .NET languages, and then of course we have our Android Room database, which is also an ORM. Hopefully the big picture of the whole point of the Android Room library is clear to you. It is a simple abstraction layer that sits on top of all the complicated SQL database syntax underneath. We interact with plain and simple Java or Kotlin code in Android Room, simple functions, passing in objects, receiving objects, simple as that. Okay? So that ends pretty much most of the theory with what databases are, with what SQL is, with what the Android Room library is. We can now get going now with the nuts and bolts of using Room to create, read, update, and delete data, and start getting the functionality of our task app working.